So hopefully by now you are pretty good at simplifying rational expressions, and I think we're ready to manipulate our rational expressions by adding and subtracting them or multiplying and dividing them. So let's start with multiplying and dividing. But just like last time, before we begin, I'm going to work with some rational numbers and then work with some rational expressions. Okay, so we have 4 over 5 times 10 over 16. So there are a few ways to do it. You can just multiply the numerators and denominators, or before you begin to multiply, you want to look for some common factors between values in the numerator and values in the denominator. Okay, you don't want to look at denominators, like looking at factors of 5 and factors of 16. You want to look at the numerator and the denominator. So, for example, 4 and 16, there's a common factor of 4. Between 5 and 10, there's a common factor of 5. So instead of saying 4/5 times 10 over 16, you can now have a much easier question. In fact, I can keep going. I didn't notice that, but whoa, we can keep going. 2 and 4, 1 over 2. So really, it's now, instead of 4 times 10 in the numerator, you have 1 times 1. And in the denominator, you have 1 times 2. So that's obviously 1 over 2. So if this is not how you normally multiply rational numbers, I think this will be very helpful because that's basically the approach we're going to take when we work with rational expressions. All right, so here, this is a division question. So we want to change it. Well, you have 1/2 divided by 1 over 6. And when you divide by a fraction, you have to multiply by the reciprocal. Okay, so 1/2 times 6 over 1. Okay, and just like before, you want to look for common factors between numerator and denominator. So between 6 and 2, there's a common factor of 2. So that's just 3 over 1, which is 3. Okay, so when you're multiplying rational numbers, look for common factors between numerator and denominator. Now when you're dividing fractions, before you look for common factors, you have to take the reciprocal of the fraction you're dividing by. All right, so in this case, since you're dividing by 1 over 6, you multiply by 6 over 1, or just 6. And once you've changed it to a multiplication question, and then you're ready to look for common factors between the numerator and the denominator. All right, so time to work on some rational expressions. All right, so what do we have here? We have this nice rational expression. You have a squared plus 2a all over 3a times 20a squared over all of 5a squared plus 10a. And then the first step is to factor. So why is it important to factor whenever possible? How else can we determine common factors between numerator and denominator? Okay, if you want to simplify by finding common factors between the numerator and denominator, you want to factor the numerator and denominator. There's no other way to identify the factors. Okay, with rational numbers, you just need to know your times table, but with these polynomials in the numerator and denominator, you have to factor. So for the way I wrote step 2, I didn't cancel it out earlier. I didn't cancel the common factors. I could have done it, but I didn't. But anyways, we'll do it here now. Okay, so I'm going to say, oh, a plus 2. Nice, common factor. Between 20 and 5, there's a common factor of 5. Okay, I have a common factor of a here. All right, so we have 4a squared left in the numerator and 3 left over in denominator. 4a squared over 3. Okay, and if there's ever like a common factors left over, it's okay. Just take another step. If you miss a common factor, that's fine. Just take another step. But anyways, in this case, it is 4a squared over 3. All right. So state restriction on variable. What can a not be? Well, a can't be 0, nor can it be -2. because you have a factor of a plus 2 in the denominator, and you have 3a and 5a. So a can't be -2, nor can it be 0. Because if a takes on any of those two values, the expression is undefined. All right, so let's try this one. So, division. So some students, they like to take the reciprocal right away. Now, I would advise against that because, I'll show you why I'm going to advise against it. So, first thing I'm going to do is actually just factor. Okay, so the greatest common factor here is 2x. Simple trinomial. Multiplies a -10, adds the -3. Multiplies a 20, adds to -9. All right, now I'm going to take the reciprocal. All right, I'm hoping for a lot of common factors here. So it simplifies nicely. Okay, I have a common factor of x minus 5. I have a common factor of 2 and a common factor of x. All right, so I have two factors of x minus 4 left over in the numerator. I have 2x and a factor of x plus 2 left over in the denominator. Okay. So now I'm going to state my restrictions. All right, so in the numerator, here I have x can't be 4, 5, -2, 4, 5, and 0. So x cannot be -2, 0, 4, 5. I like to write it in ascending order, just so it's easy for me to mark when, yeah, because if they're all scrambled, as a teacher, it's just really hard to mark. Yeah, so that's just a personal preference. I won't take off marks, but I really hope students write it in ascending order for me. Okay. Why did I not take the reciprocal right off the beginning? I could have, but I highly don't recommend that for students, because if you take the reciprocal right away, you might miss some restrictions. Okay, so if I hide this step over here, oops, I can't see anything. Well, if I hid this first line here, and all you see is x minus 5 and x minus 4 in the numerator, you will miss the restriction of 4. Okay, you'll never know because you never saw in the denominator when it was factored. So if you take the reciprocal right away, you may miss the restriction of 4 because you don't think about looking in the numerator when you're stating restrictions. But in this case, it actually makes sense to look in the numerator because you can't, when you divide, you can't divide by zero, nor can you divide by undefined. So that's why you have to look in the numerator and the denominator in order to state restrictions in this case. You know what? Just don't look. Just don't take the reciprocal right away. That's my best advice. And if that's the case, you are very unlikely to miss the restrictions. All right. So this one multiplying. Oh, and it's even partially factored for you. Now here, be careful. I see 2 minus x and I get really worried because that factor is written very in a strange manner, because you should really, there's like a -1 being hidden inside here. So I'm going to factor out -1. Difference of squares. And then multiplies 18, adds 9, 6, and 3. Okay. So now I see a common factor of x minus 2. I have a common factor of x plus 6. Beautiful. And that's about it. Okay, so this simplifies to x plus 2 in the numerator, x plus 3 all over 2 times x plus 6. Oh, and don't forget to state the restrictions. All right, so what are restrictions? X can't be 2, X can't be -6. And there we go. So that's how we multiply and divide rational expressions. Okay, so now we are ready to add and subtract rational numbers, because that's going to help prepare us to add and subtract rational expressions. All right, we have 3 over 2 plus 5 over 7. So when you add rational numbers or subtract rational numbers, it's different from multiplying and dividing in the sense that you need a common denominator. Okay, so between 2 and 7, the lowest common denominator is 14. So this would be 3 over 7, oh sorry, 3 times 7 plus 5 times 2 all over 14. Okay, so that's going to be, 1 second, 21 plus 10, which is 31. And there you go, 31 over 14. How about here? 6 and 5 is the denominator, so lowest common denominator is 30. So we have 25 minus 12, which is 13. 13 over 30. Can't reduce that because there are no common factors between 13 and 30. Beautiful. Awesome. All right, now, one of the big misconceptions that students have is that in order to find the lowest common denominator, you simply multiply the denominators. Like, for example, for the first, for example 5, 2 times 7. That's the lowest common denominator. Well, be careful, okay? It's not always the case. So if I gave you like a simpler example, if it was like 1/3 and 1/9, like 1/3 plus 1/9, I'm really hoping you wouldn't say, like if I have 1/3 and 1/9, I'm really hoping you wouldn't say that the lowest common denominator is 27, because the lowest common denominator is 9. So I know you haven't done these calculations in a while, but the most important thing is to understand, how do you find the lowest common denominator? Okay, how do you find, because I have 84 and 72. Well, this is how you find the lowest common denominator. I'll do it and then I'll write it down. So please don't multiply 84 and 72, because that won't do the trick. So what I'm going to do to 84, I really don't want to say the words, but it's very reminiscent of what you did in elementary school. 84, 12 times 7. And then 12 is 4 times 3, and 4 is 2 times 2, and then I have to stop. And then what about 72? And we do exact same thing. 72 is 9 times 8, 3, 3, 2, 4, 4, 2, 2. So in case you haven't realized, I am taking each of the denominators and prime factorize denominator. So I'm actually teaching my son how to do this right now. Well, he can actually prime factorize the numbers. You just need to know your times table. So why is it useful to prime factorize? Because when you prime factorize, you're basically telling yourself like the building blocks of a number. So how do you build the number 84? You need 2 2s, a 3, and a 7. Okay? Because your building blocks are your prime numbers. How do you build a 72? You need 3 2s and 2 3s. All right, so you know what? Let's write that down. So 1 over 84. So I'm going to need 2 2s. Instead of writing 2 squared, I'm going to write it out. I could write it as 2 squared, but I won't. All right, plus 3 factors of 2, and then 2 factors of 3. Okay, so what's the lowest common denominator? Well, this denominator of my second rational number has 3 factors of 2. Okay, so guess what? I need the lowest common denominator will have 3 factors of 2, 2 factors of 3, and 1 factor of 7. 1 factor of 7. I don't even care what the number is. I just need to know how to build the lowest common denominator. So if I'm looking at the first rational number, what factor was it missing to build this lowest common denominator? Well, it has 2 factors of 2, but the lowest common denominator has 3 factors of 2. So it's missing 1 factor of 2, and it's missing 1 factor of 3, because it only had 1, but you need 2 factors of 3 to build the lowest common denominator. It's like Lego. Now, the second rational number, what was it missing in the denominator? To build the lowest common denominator, it needed a factor of 7. And there you go. So now you can 2 times 3 is 6, 6 plus 7, 13. Beautiful. That's 8 times 9 is 72, 72 times 7, 504. There you go. That's how you find the lowest common denominator. You're used to really simple numbers in the denominator. But if it's not as simple, then just prime factorize, and you'll know what are the prime numbers that you need in order to build the denominator. Now, why did I bring this up? Because when you work with rational expressions, this is the logic you really need to employ. How am I building the lowest common denominator? What are the factors? So here we have 1 over 5x plus 1 over 2x. So 1 over 5, what's the lowest common denominator? Well, a factor of 5 and a factor of 2. So really, between 5 and 2, the lowest common denominator is 10. And they both have a factor of x, which is perfect. So this is going to be 1 times the missing factor, which is 2. And this is going to be missing factor 5. So 5 plus 2, 7 over 10x. Restrictions, of course. X cannot be 0. Beautiful. All right, over here, ooh. So, what are we missing here? Oh, perfect. This the denominator 2ab squared isn't missing anything. In order to build the lowest common denominator, it's actually the second rational expression. I have to, this is missing a factor of a and a factor of b, and then we can build the lowest common denominator of 2ab squared. So missing factor of a and b, so it's ab times all of b plus 2. So I'm going to expand. Watch your expansion. No silly mistakes. Distribute the negative. So it's negative ab squared and minus 2ab. Okay, that simplifies. Very nice, very nice. Minus 2ab plus 2. And wait a minute. Now this doesn't happen very often, but after I simplify the numerator, I realize that there's a common factor of 2 between the numerator and denominator. So I have to simplify. I can factor out 2, but you know what? I'm pretty confident you can see this. I'm going to just divide everything by 2. So it's minus ab plus 1 over ab squared. Restrictions. A can't be 0, b can't be 0. Because if either a or b is 0, then 2ab squared is 0. We don't want that. Okay, over here we have, not much you can do over here. The lowest common denominator is x minus 1 times all of x plus 2. So the building block that we're missing here, we had to take x plus 5 and multiply by the factor of x plus 2, because that was the missing factor to make the lowest common denominator. Whereas x minus 7, I'm going to multiply by the missing factor of x minus 1. All right, and then just take your time, expand. Alright, so that's 2x squared minus x plus 17. State restrictions. Negative 2 and 1. Now here, you can't simplify any further because 2x squared minus x plus 17, you can't factor that, which means there's no common factor between numerator and denominator, so you're pretty much done. All right. Ooh, okay. All right. What's the lowest common denominator? Well, it's very hard for me to tell you right now because I need this to be factored, right? I cannot possibly tell you. I need to tell myself the building blocks. In order to do so, I have to have them factored. So x plus, what multiplies 8 and 6? So it's 8 and negative 6. Okay, so we follow our analogy, then x minus 6 is already a common building block. Okay, it's a common factor between the two denominators. So really, this denominator is missing a factor of x plus 5, and this one is missing a factor of x plus 8. And then you'll have the lowest common denominator of x plus 8 times x minus 6 times x plus 5. All right, so I'm going to take all of x plus 9 and multiply by x plus 5 minus all of x minus 9 times x plus 8. All right, so just take your time here. It's a very, very common mistakes here, so just be very careful with your algebra. I can skip some steps, but I would recommend against it. If you want to save time, just practice your factoring, because that will save you ample time already. All right, so let me just triple check. Minus x, good. Minus 7, 2. Beautiful. Okay, and be careful. Just subtract, you need the brackets here. The most common mistake for the test is just students forgetting that they're subtracting by the trinomial. They forget the brackets. Because if you don't put the brackets, you're subtracting by a monomial, which is very different from subtracting by a trinomial. All right, so this will be 15x. This will be 45 plus 72, which is 117. State restrictions. I've got negative 8, negative 5, and positive 6. Okay, last two. So we have 4x minus 3. Okay, now here, if you factor out negative 1, it's beautiful because then you have x minus 4 and this becomes plus. So I'll show more steps, but you'll see this in the homework. And let's do this. Right? It's like subtracting by a negative number, which means you're adding. If you want to see an analogy, like this is analogous to, I don't know, let's say 2/3 minus 5 over negative 4. So that'd be 2/3 plus 5/4. It's exactly the same thing. And beautiful, common denominator. Oh, perfect. I don't do any work. It's 10x plus 2. Is there a common factor between numerator and denominator? Nope. So there's no simplifying that can take place. X cannot be 4. Beautiful. All right, let's keep going. X plus 2, x minus 2, difference of squares. X plus 2, x plus 1. Ooh, beautiful. I can simplify right away. Well, let's investigate my next expression first. Oh, I can simplify again. This is beautiful. Okay, so lowest common denominator is just x plus 1, x minus 1. All right. Plus minus 3x plus 2. Be careful, subtract the whole trinomial here. X squared minus 2x minus 3. Just enough room here. Perfect. So that distribute, so that's 2 negative x plus 5. State the restrictions. X cannot be negative 3, negative 2, plus minus 1. Perfect. I just want to add one little detail because students do this all the time, and I don't want anyone to make this mistake, so I'll just make up a real quick expression here. I guess I could have brought this up when I was talking about simplifying rational expressions. So some students, they don't know when to stop. Okay, you need to know when you can't simplify any further. So some students, when they see this, they go crazy and they write that. I don't even know what they write afterwards, but let's say they write 1/2, or I don't know. But the idea is they see something and they just want to cancel out. They see that there are terms which are common between the numerator and the denominator. So when we're simplifying, we're not looking for common terms between numerator and denominator. You're looking for common factors. Okay, that's why you want to put in factor form. Like, this is insane, okay, to think about it, because that's like me saying I see a 3 here and I see a 3 here, I'm going to just cancel them out. Like, that's just crazy. You can't cancel out. It's not common factors. But if it was this, absolutely. Okay, so it's the idea, the understanding what a factor is, which some students don't see. So please understand what it means to be a factor, and then you will know when you can stop simplifying the expression, or when you can no longer simplify the expression.